Welcome to the Bedtime Lab, your cozy corner of the universe, where we explore the mysteries of life both here on Earth and out among the stars. I'm so glad you could join me tonight as we delve into the dreamy realm of extraterrestrial life. It's a topic that has fascinated us for centuries and continues to ignite our imagination and curiosity. But before we journey into the stars, I'd love to know where in this vast world you're listening from. So, go ahead and share in the comments. It's amazing to think how we're all connected under the same sky, isn't it? Now, let me share something interesting with you. Did you know that one of the earliest recorded speculations about life on other planets dates back to the ancient Greeks? A philosopher named Anaxagoras suggested that life might exist on other worlds. Imagine that, even 2,400 years ago, humans were wondering about neighbors among the stars. Speaking of ancient musings, did you know that the term extraterrestrial literally means beyond Earth? It's a simple yet profound reminder that our quest to find life beyond our little blue planet is not just a modern pursuit, but a timeless adventure, and this quest has taken us to some unexpected places. For instance, the search for extraterrestrial life isn't limited to scientists scanning the skies with telescopes. It also includes the study of extremophiles right here on Earth, tiny organisms that thrive in extreme conditions, like deep-sea hydrothermal vents or acidic lakes. These resilient creatures show us that life can flourish in the most unlikely places, suggesting that life beyond Earth might be more common than we think. Here's a fascinating fact for you. The famous Drake equation, conceived by astronomer Frank Drake in 1966, provides a framework to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. While the equation is filled with variables and uncertainties, it captures the hopeful spirit of scientific inquiry. Can you imagine a world where we might actually contact another civilization? Another point of wonder is the sheer number of stars in the universe. Our galaxy alone, the Milky Way, contains roughly 200 billion stars, and when you think about the fact that there are more galaxies in the observable universe than there are grains of sand on all the beaches on Earth, it truly boggles the mind. Each of these stars could potentially host planets, and with recent advancements in technology, we've discovered thousands of exoplanets orbiting distant stars. Some of these planets reside in what we call the habitable zone, where conditions might be just right for life as we know it. And here's something that might surprise you. One of the most iconic messages sent into space is the Golden Record, launched aboard the Voyager spacecraft in 1977. This phonograph record contains sounds and images representing the diversity of life and culture on Earth. It's a time capsule intended to communicate the story of our world to extraterrestrials. Imagine if someone or something found it one day. Speaking of messages, did you know that in 1974, humans sent a radio message known as the Arecibo message out into space? This message was designed to demonstrate our technological abilities and contained basic information about humanity and Earth. It was aimed at a cluster of stars over 25,000 light-years away. While it will take a long time to reach its destination, it stands as a testament to our desire to connect with the unknown. But our search for extraterrestrial life isn't limited to sending messages. We're also listening. The SETI Institute, which stands for the Search for Extraterrestrial Intelligence, uses radio telescopes to listen for signals from other civilizations. The idea is simple. If they are out there and technologically advanced, They might be trying to reach us too. Here's another dreamy thought. Some scientists are exploring the possibility of life on Europa, one of Jupiter's moons. Beneath its icy surface lies a vast ocean that might harbor life. The Europa Clipper mission, set to launch in the next few years, aims to study this mysterious moon in greater detail. Imagine what we might discover below the icy crust. And let's not forget about Mars. Our fascination with the red planet has only grown stronger with each passing mission. From the rovers exploring its dusty surface to the discovery of ancient riverbeds, Mars continues to tease us with the possibility that life might have existed there long ago, or perhaps even now. In our cosmic journey, we also find ourselves wondering about the concept of panspermia, the idea that life might have spread from one planet to another, traveling on meteoroids or comets. Could life on Earth have originated elsewhere? Or could Earth be the cradle of life, sending tiny seeds of life into the cosmos? As we drift deeper into this night of exploration, I hope you feel the wonder and mystery of the universe wrapping around you like a soft, starry blanket. With every discovery, every question, and every possibility, we take one step closer to understanding our place in the universe. So, let your mind wander among the stars as you settle in for a peaceful night's rest. Who knows what dreams might come? Let's journey further into the infinite tapestry of the cosmos, where each thread is woven with curiosity and discovery. Did you know that scientists have found a surprising connection between the search for extraterrestrial life and the study of our own oceans? The extreme environments of Earth's deep-sea ecosystems, where sunlight never reaches and life thrives around hydrothermal vents, provide a model for what life could be like on other worlds. If life can exist in such inhospitable places here, who's to say it couldn't exist elsewhere under similar conditions? Speaking of life's resilience, here's something intriguing. Tardigrades, often called water bears, are tiny creatures that can survive in the vacuum of space. These resilient beings have an extraordinary ability to endure extreme radiation, temperatures, and pressure. This raises the fascinating possibility that similar life forms might exist beyond our planet, perfectly adapted to the harsh environments of space. In our quest to find life's traces, we often turn our eyes to the skies. A lesser-known project is Breakthrough Listen, an initiative that aims to detect intelligent life by scanning the skies for unusual radio signals. With state-of-the-art technology, this project listens to the universe, akin to eavesdropping on a cosmic conversation, hoping to catch the whispers of distant civilizations. And here's a delightful thought. The idea of life on Venus has recently regained attention. In 2020, scientists detected phosphine gas in Venus's atmosphere, a potential indicator of microbial life. While Venus is often dismissed due to its harsh surface conditions, this discovery hints at the possibility of life in the clouds, where temperatures are more moderate. Did you know that the mysterious Oumuamua, the first known interstellar object to pass through our solar system, sparked discussions about extraterrestrial technology? Its elongated shape and unusual trajectory led some to speculate it might be an alien probe or spacecraft. While this remains speculative, the excitement it generated reminds us of the endless possibilities waiting to surprise us. A whimsical notion comes from the study of Dyson spheres, a hypothetical megastructure that an advanced civilization might build around their star to capture all its energy. Imagine an entire star surrounded by a massive solar panel. Search efforts include looking for stars with unusual dimming patterns that might indicate such a structure. Our moon may seem like an unlikely place for life, but did you know that some scientists speculate it could harbor clues about extraterrestrial visitors? The Moon's surface, relatively unchanged due to the lack of atmosphere, could preserve ancient artifacts or signs of past alien visits, waiting to be discovered by future missions. In the realm of science fiction becoming reality, this term refers to a civilization existing on an exoplanet, which is any planet outside our solar system. With the discovery of so many exoplanets, the idea that some might host intelligent life becomes a tantalizing possibility. Allow me to share a thought-provoking angle. Some researchers propose that our own technological advancements, like artificial intelligence, might be mirrored by alien civilizations. If we can create machines capable of thinking and learning, what if extraterrestrial beings have done the same? It's a curious parallel that could redefine how we search for signs of life. Imagine a world where the universe itself is alive. The Gaia hypothesis suggests that planets and their ecosystems function as a single organism. Some scientists extend this idea to the cosmos, pondering if the universe could exhibit traits of life, such as self-regulation and adaptation. It's a mind-expanding concept that blurs the line between life and the cosmos. On a more tangible note, the discovery of amino acids in interstellar space provides a thrilling link to the origins of life. These building blocks of life have been found on comets and meteorites, suggesting that the ingredients for life are scattered throughout the galaxy, potentially seeding planets with the basics needed for life's genesis. Did you know that scientists are also exploring the potential of biosignature gases like oxygen and methane as indicators of life? These gases, when found together in an exoplanet's atmosphere, could suggest the presence of biological activity. Advanced telescopes are being developed to detect these subtle signs, guiding us ever closer to identifying habitable worlds. Lastly, let's ponder the concept of a shadow biosphere. This idea posits that there could be microbial life on Earth that's so different from known life forms that it remains undetected. If such life exists here, it broadens the possibilities for the forms life might take elsewhere in the universe, reminding us that the unknown might be closer than we think. As we sail through this cosmic ocean, each fact serves as a gentle beacon, lighting our way through the vast and wondrous universe. These musings, like stars, guide us in our ceaseless quest for understanding, leaving us with a sense of awe and anticipation for what the next discovery might reveal. Let your thoughts drift like stardust, filled with dreams of distant worlds and the endless possibilities they hold. Speaking of the infinite cosmos, have you ever wondered about the role of exomoons in the search for extraterrestrial life? These are moons that orbit planets outside our solar system, and they could be as abundant as the planets themselves. Just imagine an entire galaxy filled with moons, each potentially harboring its own unique ecosystems. Some scientists believe these exomoons might be more hospitable to life than the planets they orbit, given their potential for geological and atmospheric stability. On a related note, Jupiter's moon Europa has been a focal point of interest when it comes to the search for life. Beneath its icy crust, Europa is believed to hide an ocean of liquid water, kept warm by the gravitational pull of its parent planet. Could there be life swimming in those dark depths, much like the deep-sea creatures on Earth? This tantalizing prospect has inspired missions specifically aimed at exploring this hidden ocean world. The concept of panspermia also offers a fascinating perspective. It suggests that life might not have originated independently on Earth, but was instead seeded by biological materials carried here by comets or meteorites. If panspermia holds true, it implies that life could be scattered across the universe, suggesting a cosmic kinship between planets. Did you know that the study of extremophiles, organisms that thrive in Earth's most hostile environments, has provided insights into what life might look like on other planets. These hardy organisms have been found in the boiling hot springs of Yellowstone, the acidic rivers of Spain, and even the radioactive ruins of nuclear reactors. Their existence challenges our understanding of life's limits and fuels the imagination about where life might exist beyond Earth. Here's a curious thought. The search for extraterrestrial life isn't limited to organic beings. Researchers are also considering the possibility of silicon-based life forms. Silicon, like carbon, has the ability to form complex molecules, and under the right conditions, silicon-based life could potentially thrive. This idea expands the scope of our search, encouraging us to look beyond the carbon-centric lens through which we've traditionally viewed life. And have you ever pondered the concept of techno-signatures? These are signs of advanced technology that could indicate the presence of intelligent civilizations. Unlike radio signals, which might only be detectable for a short period, techno-signatures such as large-scale energy use or the construction of massive structures might be more persistent. This shifts the focus from listening for alien communications to observing the broader impacts a civilization might have on its environment. One intriguing area of study is the possibility of life existing in subsurface oceans on distant exoplanets. These oceans could be protected by thick layers of ice, creating stable environments that shield life from the harsh conditions of space. The warmth from a planet's core or tidal forces could sustain these hidden oceans, much like those believed to exist on some of Jupiter's and Saturn's moons. Imagine the excitement of discovering microbial life forms that rely on chemical reactions rather than sunlight for energy. Such organisms, called chemolitho-autotrophs, are found in Earth's deep-sea hydrothermal vents and hot springs, thriving in environments that were once thought to be inhospitable to life. Their existence suggests that similar life forms could exist on other planets, drawing energy from the chemical reactions taking place beneath the surface. Let's take a moment to consider the possibility of ancient alien civilizations that have long since vanished, leaving behind only traces of their existence. These remnants might be detectable through archaeological methods adapted for space, revealing clues about the rise and fall of alien societies. Such discoveries could offer profound insights into the trajectory of intelligent life and its potential future. Have you ever heard of the concept of a galactic habitable zone? Just as there are regions around stars where planets are more likely to support life, there are areas within galaxies where conditions might be more favorable for life to develop. These zones are influenced by factors like radiation levels, the availability of certain elements, and the frequency of catastrophic events. This idea paints a picture of our galaxy as a diverse landscape of potential life-bearing regions. Speaking of diverse landscapes, the discovery of planets orbiting red dwarf stars has expanded our understanding of possible habitats for life. These stars are smaller and cooler than our Sun, but their abundance and long lifespans make them intriguing targets in the search for life. Planets in these systems could have stable climates and a greater chance for life to develop over billions of years. The possibility of intelligent life is often romanticized, but the idea of finding simple microbial life is equally profound. Discovering even the simplest organism on another planet would revolutionize our understanding of biology and the origins of life. It would suggest that life is not a unique earthly phenomenon, but a cosmic imperative, waiting to emerge wherever conditions allow. Lastly, consider the notion that alien life might communicate in ways we haven't imagined. Beyond radio waves or visual signals, They might use methods that are entirely alien to us, perhaps involving technologies or mediums we have yet to discover. This possibility encourages openness to new ideas and collaborations across disciplines as we continue our search. As we delve deeper into these intriguing theories and ongoing discoveries, each new piece of information broadens our perspective. It's like slowly piecing together a cosmic puzzle, where each fact helps illuminate the vast tapestry of the universe, inviting us to dream and wonder about the extraordinary possibilities that await. Let your imagination wander through these interstellar musings, where the boundaries of reality and speculation dance, creating a lullaby of cosmic curiosity. Let me share something intriguing with you: the idea of life existing on rogue planets, those mysterious wanderers that drift through space without orbiting any star. These planets, untethered and alone in the vastness of the cosmos, might still harbor life if they have a thick enough atmosphere to retain heat, or if geothermal processes are active beneath their surfaces. Imagine the hidden worlds they could be, cradling life in the dark. And here's another astonishing thought. Some scientists are investigating the possibility that life could be based on entirely different chemistries than we know, such as ammonia-based life. Ammonia, with its own set of unique properties, could serve as an alternative solvent to water, potentially supporting life forms in environments where water is scarce or frozen. Speaking of unique environments, did you know that the moons of the outer planets, like Neptune's Triton and Uranus's Enceladus, are captivating targets in the search for extraterrestrial life? These icy moons might host subsurface oceans heated by tidal forces or radioactive decay, providing a habitat for life independent of sunlight. Research missions to these distant moons could uncover secrets that redefine our understanding of life's potential habitats. Another thought-provoking concept is the idea of mirror life, where organisms have a reversed molecular chirality compared to life on Earth. Our biochemistry relies on specific orientations of molecules, but mirror life would be built from left-handed or right-handed versions of these molecules, challenging our notions of biochemistry and possibly going undetected by traditional methods. Have you ever pondered the role that cosmic dust plays in the potential for life? This seemingly inert material, adrift in space, carries organic compounds and can be a catalyst for chemical reactions when it interacts with starlight or other radiation. Cosmic dust could be a key player in the early stages of life formation, sprinkling the building blocks of life across planets and moons. Consider the possibility of life in the clouds of Venus. The planet's surface is a hellscape of crushing pressure and scorching temperatures, yet its upper atmosphere presents a more temperate environment. Some scientists speculate that microbial life could exist within the dense cloud layers, surviving on sulfuric acid droplets and perhaps using ultraviolet light for energy. A fascinating area of study is astrobiological engineering, where scientists explore the idea of artificially creating environments suitable for life. By understanding how life adapts and thrives in extreme conditions on Earth, researchers hope to apply this knowledge to terraform planets or moons, making them habitable for future generations. And did you know that the search for life beyond Earth also involves looking for biosignatures in the atmospheres of exoplanets? These are chemical markers, like oxygen or methane, that could indicate the presence of biological activity. Advances in telescope technology have made it possible to analyze the light passing through distant planetary atmospheres, revealing tantalizing hints of what might be happening on their surfaces. Imagine the possibility of encountering life forms that evolved from entirely different evolutionary processes. While Earth's evolution follows the path of natural selection, alien life could have arisen through mechanisms we can scarcely imagine, leading to forms and functions that defy our current understanding of biology. Speaking of evolution, consider the notion that intelligent extraterrestrial civilizations might be technologically advanced beyond our comprehension yet choose to remain silent. This idea, part of the zoo hypothesis, suggests that aliens might be observing us from afar, much like animals in a nature preserve, deliberately avoiding contact to allow natural development. Have you ever thought about the role of cosmic radiation in the potential for life beyond Earth? While often perceived as destructive, radiation can drive chemical processes that might contribute to the formation of simple life forms. In environments with the right balance, radiation could be a catalyst rather than a barrier to life. Consider the possibility of life on planets orbiting binary star systems. These systems, which contain two stars, could offer planets unique climates and environmental conditions that might be conducive to life. The presence of two suns could create fascinating cycles of day and night, impacting everything from temperature regulation to photosynthesis. And then there's the consideration of life existing in the most unexpected places on Mars, possibly sequestered within underground caves or lava tubes. These subterranean environments could protect life from the harsh surface conditions and provide stable habitats where water ice might persist in liquid form. Have you heard of the idea that some stars might host civilizations that have harnessed their energy output, creating vast structures like Dyson spheres? These hypothetical megastructures, built to capture a star's energy, could be indicators of advanced technological civilizations. Detecting anomalies in starlight could hint at such engineering marvels. Lastly, think about the potential for life on planets that experience intermittent habitability, where conditions for life are transient. Such planets might undergo cycles of habitability driven by orbital changes, volcanic activity, or other factors. Life here would need to be incredibly resilient, adapting to rapidly shifting environments, much like some extremophiles on Earth. As you drift into the realm of dreams, let your mind wander through these cosmic possibilities, each fact a star twinkling in the night sky of your imagination. Each piece of this vast puzzle invites you to ponder the universe's mysteries, sparking wonder and curiosity that beckon you to explore further. Let me share something intriguing with you. Scientists are beginning to consider the possibility of life existing in the shadows of gas giants. These massive planets, with their thick atmospheres and swirling storms, might host life in regions shielded from harsh radiation, where conditions are more stable and conducive to survival. It's fascinating to think about what kind of life forms could thrive in such dynamic and turbulent environments. Speaking of unfamiliar habitats, did you know that our own solar system's asteroid belt might hold clues to ancient life? The belt is a treasure trove of primordial material, possibly harboring organic compounds and information about the early solar system. By studying these space rocks, we might uncover hints of life's origins, or even evidence of microorganisms that once traveled through space on these rocky vessels. Here's a thought-provoking idea. Life might exist in the form of plasma-based organisms in the atmospheres of stars. Imagine creatures composed of charged particles, thriving amidst the intense heat and energy of a stellar environment. Such life forms would be unlike anything we've ever encountered, challenging our understanding of what constitutes a living being. Can you imagine life evolving on a planet with a tilted axis, leading to extreme seasonal changes? These planets, known as obliquity planets, could have environments that cycle between habitable and inhospitable conditions. Life here would need to be incredibly adaptable, perhaps entering dormant states during harsh seasons, only to thrive when the conditions become favorable again. And then there's the idea of life existing in the vast, dark expanses between galaxies, in what is known as intergalactic space. This space is not as empty as it seems, filled with gas and dust that might support simple life forms, drifting alone in the cosmic void. It's a humbling thought, considering the isolation and resilience required for life to exist in such remote locales. Have you ever pondered the role of rogue planets in the search for life? These planets wander the galaxy unbound by a solar system, yet they might still support life with internal heat sources or thick atmospheres that trap warmth. Life on rogue planets would need to be uniquely adapted to survive without the light and warmth of a nearby star. Imagine the potential for life forms that communicate through chemical signals rather than sound or sight. In environments shrouded in darkness or beneath thick ice, organisms might rely on complex chemical exchanges to convey information. This could lead to entirely different social structures and interactions, unlike anything we observe in Earth's ecosystems. Here's something to consider: the presence of life in the remnants of ancient star systems, where the heavy elements necessary for life have been produced by supernova. These stellar explosions distribute essential materials like carbon, oxygen, and nitrogen, seeding new star systems and potentially sparking the formation of life in their wake. Did you know that some scientists are exploring the concept of life forms that derive energy from magnetic fields? In areas with powerful magnetic activity, such as near neutron stars or pulsars, life might harness these forces in ways we can't yet imagine. Such organisms would redefine our understanding of energy utilization in biological systems. Let's delve into the idea of life existing in artificial habitats crafted by advanced civilizations. These habitats could be constructed to preserve and nurture diverse life forms, perhaps even serving as arcs that travel between stars. The ingenuity required to create and sustain such environments speaks to the potential of life to transcend its planetary origins. And then there's the fascinating possibility of life on planets with extreme atmospheric pressure, where organisms might be adapted to survive under crushing forces. These life forms would have evolved unique physiological mechanisms to withstand conditions that would be utterly inhospitable to Earth-based organisms. Consider the potential for life in environments with variable gravity, where the force of gravity shifts due to the influences of nearby celestial bodies. Organisms in such places might evolve with flexible structures capable of adapting to changing gravitational forces, leading to life forms with extraordinary physical capabilities. Have you ever imagined the concept of life in an entirely liquid world, where land masses are absent and the entire planet is covered in oceans? In such a world, life would likely be aquatic, with ecosystems developing in 3 dimensions, creating a complex web of interactions and adaptations across the entire planet. Lastly, think about the potential for life forms that use quantum processes as part of their biology. These organisms might exploit quantum mechanics in their metabolism or communication, utilizing phenomena like entanglement or tunneling. This would open up a realm of possibilities for exotic life forms that challenge the boundaries of our scientific understanding. As you drift deeper into the serene comfort of sleep, let these thoughts weave a tapestry of cosmic wonder in your mind. Each fact, a gentle whisper of the universe's possibilities, invites you to dream of worlds and life forms beyond our wildest imagination. Embrace the mystery and let it guide you through the starlit corridors of your dreams, sparking curiosity and awe that will linger long after you've awakened. Did you know that some scientists speculate about life existing in environments dominated by radiation, such as those found around black holes? It's a mind-boggling thought that life could find a way to adapt to the intense radiation and gravitational forces present in these regions. Imagine organisms that not only withstand such extremes, but thrive within them, potentially using the energy from radiation in a process akin to photosynthesis. Here's an intriguing idea: the potential for life forms that exist entirely in the gaseous layers of gas giants like Jupiter or Saturn. These hypothetical creatures, often referred to as floaters, might drift through the thick atmospheres, using buoyancy to navigate their vast homes. It's possible they could derive energy from chemical reactions occurring within the planet's atmosphere, living in a world that is forever suspended in a sea of clouds. Have you ever considered the possibility of life evolving on planets orbiting red dwarf stars? These stars are smaller and cooler than our Sun, but they are the most common type in our galaxy, providing numerous potential cradles for life. Planets in these systems might be tidally locked, with one side constantly facing the star, creating a dynamic environment where life would have to adapt to perpetual daylight or eternal night. Let me share something fascinating. Scientists have pondered the existence of life that communicates through vibrations in solid matter. On planets where sound waves travel differently due to dense materials, organisms might use subtle vibrations to send signals through rock or ice, creating a symphony of communication that is entirely alien to us. And here's a thought-provoking notion: the idea of life forms that use natural superconductors as part of their physiology. In the extreme conditions of certain exoplanets, materials might exhibit superconductivity at unexpectedly higher temperatures, allowing organisms to use these properties for efficient energy transfer or communication. Did you know that there's a possibility of life existing on carbon-rich planets, where diamond-like structures dominate the landscape? These diamond planets could host unique ecosystems that are starkly different from Earth's carbon-based life, with life forms possibly utilizing silicon-based chemistry or other unusual molecular structures. Speaking of unusual biochemistry, have you heard of the concept of life using sulfur instead of oxygen for respiration? In environments rich in volcanic activity or deep beneath thick ice layers, organisms might evolve to thrive on sulfur, turning what is typically a corrosive element into a vital resource for survival. Imagine life forms that navigate the cosmos using natural magnetic fields, almost like cosmic compass needles. These creatures could potentially travel vast distances by aligning themselves with magnetic lines, gliding through space in a way that defies our traditional understanding of movement. Here's an interesting concept: the possibility of life forms that are perpetually in a state of metamorphosis, adapting their physical forms to the changing conditions of their environment. This constant transformation could be a strategy for survival in worlds where change is the only constant, producing creatures of incredible diversity and resilience. Consider the potential for life in environments with extreme chemical imbalances, where organisms might harness exotic chemical reactions to sustain themselves. These life forms could exist in ecosystems that appear hostile by Earth standards, yet are perfectly suited to their needs, perhaps even thriving in what we would see as toxic or acidic conditions. Have you ever imagined the idea of life forms that are so large they span entire ecosystems, functioning almost like living continents? These giant organisms might host a myriad of symbiotic life within them, creating a complex interplay of life forms that depend on one another in a self-sustaining biosphere. And then there's the notion of life forms that use light in ways we can barely conceive, possibly manipulating it for camouflage, communication, or even energy production beyond photosynthesis. These organisms might possess the ability to bend or refract light, creating dazzling displays that are both beautiful and functional. Here's a curiosity: the speculation about life on planets with multiple stars, where the ever-changing light conditions could lead to unique evolutionary pressures. Organisms on such planets might develop remarkable adaptations to cope with the varying light and radiation levels, potentially leading to life forms with extraordinary visual or protective traits. Can you picture life on a planet where the sky is filled with vibrant colors due to complex atmospheric phenomena? These atmospheric conditions might influence the evolution of life, leading to creatures that can perceive or even utilize these colors in ways that are entirely foreign to our Earth-based sensibilities. Finally, consider the potential for life forms that exist at the boundary of digital and biological, perhaps on worlds where advanced technology has become intertwined with organic life. These beings could represent a fusion of nature and machine, exhibiting traits of both in a seamless coexistence that challenges our definitions of life. As you sink deeper into relaxation, let these musings wrap around your thoughts like a soft cosmic blanket. Each idea is a gentle nudge toward a universe steaming with possibilities. Embrace the unknown, allowing the mysteries of life beyond Earth to guide your dreams into the vastness of space, where every star is a beacon of untold secrets and every world an invitation to wonder. Imagine the excitement of discovering life forms thriving in environments that we once thought were too extreme for any known organism. In the search for extraterrestrial life, one of the surprising ideas is the presence of extremophiles, organisms that live in conditions deemed inhospitable by Earth standards, such as extreme heat, cold, or acidity. These resilient life forms can be found in some of Earth's harshest environments, like deep-sea hydrothermal vents, and they inspire hope that similar organisms might exist on other planets or moons. Speaking of moons, Europa, one of Jupiter's moons, captivates scientists with its icy surface and the possibility of a vast ocean beneath. The prospect of life existing in such subsurface oceans is thrilling, and missions are being planned to explore these hidden seas in search of signs of life. Can you envision what it would be like to find simple microbial life surviving in these dark, cold waters? Let's consider another intriguing possibility: the presence of life in the clouds of Venus. Although Venus has a scorching surface temperature, its upper cloud layers have conditions that might support microbial life, with moderate temperatures and the presence of chemicals that could potentially sustain life. Imagine tiny organisms floating in the Venusian atmosphere, suspended in droplets of sulfuric acid, leading a delicate existence high above the planet's fiery surface. And here's an interesting premise: the concept of panspermia, which suggests that life might spread through the universe via comets or meteorites. This theory proposes that microbial life forms could travel vast distances across space, hitching rides on these celestial bodies and potentially seeding life on new planets upon impact. It's a captivating thought to consider that life on Earth might have originated from such extraterrestrial sources. Speaking of cosmic travelers, have you ever thought about the role of asteroids in the search for extraterrestrial life? Some scientists believe that asteroids could harbor organic compounds, the building blocks of life, providing clues about the origins of life in our solar system. By studying these space rocks, researchers hope to uncover secrets about the potential for life beyond Earth. Let me share another marvel: the possibility of life existing under the thick ice of Saturn's moon, Enceladus. This moon has piqued the interest of scientists due to geysers that spew water vapor and ice particles into space, suggesting the presence of a subsurface ocean. The thought of life forms thriving in these hidden waters, perhaps similar to those found in Earth's deep oceans, stirs the imagination and fuels the quest to explore this icy world further. Now, let's drift to the fascinating idea of techno-signatures as indicators of extraterrestrial life. These are signs of advanced technology, such as artificial light or unusual heat patterns, that could suggest the presence of intelligent civilizations elsewhere in the universe. By scanning the cosmos for these technological footprints, scientists hope to uncover evidence of life that has developed far beyond our own technological capabilities. Here's another captivating concept: the potential for life on planets with intense volcanic activity. On Earth, some of the most resilient life forms are found near volcanic vents, where they thrive on the energy and nutrients provided by these fiery environments. It's conceivable that similar ecosystems could exist on other planets or moons, with active volcanoes, sustained by the heat and chemicals produced by volcanic processes. Have you heard about the search for biosignatures, which are chemical indicators of life? In the atmospheres of distant exoplanets, scientists look for gases like oxygen or methane that might suggest biological activity. This method of searching for life pushes the boundaries of our technology and understanding, challenging us to detect the faintest whispers of life from light years away. Speaking of light years, did you know that the discovery of Earth-like exoplanets in the habitable zone of their stars is a major step in the search for extraterrestrial life? These planets are located at just the right distance from their stars to allow liquid water to exist, which is crucial for life as we know it. The discovery of such planets excites scientists and enthusiasts alike, as it narrows down the places where life might be found. Imagine the surprise of finding life forms that are entirely electric, using electricity as a means to interact with their environment. On Earth, some bacteria are known to generate electricity, and scientists speculate that on other planets, organisms might have evolved to harness electrical energy in much more complex ways, perhaps to communicate or move. Finally, let's ponder the potential for life to exist in the most unexpected places, like the dark side of exoplanets tidally locked to their stars. These planets have one side in perpetual darkness and the other in constant daylight. It's possible that life could thrive in the twilight zone, where these two extremes meet, adapting to the unique conditions of this ever-shadowy border. As you continue to relax, let the vastness of the universe and the endless possibilities of extraterrestrial life gently lull you into a state of wonder and tranquility. Each idea is like a distant star twinkling with the promise of discovery and adventure. Rest easy knowing that the universe is a place of infinite mystery, inviting you to dream of what lies beyond our small blue planet. Have you ever considered the possibility of life forms that communicate using light? On Earth, some organisms, like fireflies, use bioluminescence to convey messages. Now imagine a distant world where entire ecosystems might rely on intricate light displays to interact and survive. It's a mesmerizing thought to picture forests or oceans filled with creatures that glow in myriad colors, communicating across the landscape in a symphony of light. Speaking of unique forms of communication, think about the idea of life existing in the form of intelligent clouds. Certain theories suggest that in the right conditions, gaseous beings could develop sentience, perhaps floating in the thick atmospheres of giant planets like Jupiter or Saturn. These hypothetical cloud entities might drift, think, and communicate, shaped by the winds and storms of their expansive worlds. Now, here's a thought-provoking notion: the potential existence of silicon-based life. While carbon is the backbone of terrestrial life, silicon shares similar chemical properties and could potentially serve as an alternative foundation for life in environments vastly different from Earth. Imagine life forms with crystalline structures, thriving in extreme heat or harsh chemical conditions, their biology a testament to the adaptability of life. Did you know that scientists are considering the possibility of life on rogue planets? These are planets that drift through the galaxy without orbiting a star. Despite the absence of a star's warmth, some theories propose that life could exist beneath thick ice layers, kept warm by geothermal heat, similar to the environments found on Enceladus or Europa. And here's a mind-bending idea: the search for life in the realm of artificial intelligence. Some researchers speculate that advanced extraterrestrial civilizations might transcend biological forms and exist as data or digital consciousness. In this scenario, intelligent life might inhabit the fabric of a highly advanced technological system, exploring the universe as streams of data rather than flesh and blood. Have you ever pondered the notion of hive-mind organisms? On Earth, social insects like ants exhibit collective behavior that resembles a single entity. Imagine a planet where life forms operate as vast, interconnected networks, each individual contributing to a group consciousness, acting with a singular purpose that emerges from the unity of their collective mind. Speaking of collectives, consider the idea of life evolving in symbiosis with machines. On a distant planet, biological and mechanical entities might co-evolve, each relying on the other for survival. This fusion could result in life forms that blend organic and inorganic components, a harmony of biology and technology unimaginable by today's standards. Here's another captivating concept: life forms that use magnetic fields as a sensory system. On Earth, certain animals can detect magnetic fields for navigation. Now, picture life on planets with strong magnetic environments, where organisms might have evolved to perceive and communicate using these invisible forces, perhaps guiding their movements or even their social interactions. Can you imagine life that thrives on radiation? In the harsh environments of space, where radiation levels are detrimental to known life forms, it's possible that some organisms might not only survive, but flourish by using radiation as an energy source. Such creatures would redefine our understanding of life's resilience and adaptability. There's also the fascinating prospect of life on planets with methane seas. Saturn's moon Titan is an icy world with lakes of methane and ethane. Researchers speculate that exotic life could exist in these frigid, hydrocarbon-rich environments, utilizing methane in ways similar to how life on Earth relies on water. And while we're on the subject of extreme environments, let's not forget about the possibility of life existing entirely underground. Beneath the surface of a planet, shielded from harsh surface conditions, a whole ecosystem might thrive in subterranean caverns and tunnels, akin to the deep biosphere found beneath Earth's crust. Have you ever thought about the chances of finding life in the form of energy-based entities? Some scientists entertain the idea of life forms that defy our material expectations, existing as pure energy, interacting with their environments through different means than we can currently comprehend. Such entities would challenge our definitions of life itself. Let's also consider the possibility of life on planets with double suns. In star systems where planets orbit two stars, the unique lighting and gravitational conditions could give rise to life forms adapted to the changing dynamics of a binary sun world. These life forms might display extraordinary adaptability, thriving under two different stellar influences. And here's something to dream about: the idea of life in the multiverse. If multiple universes exist, each with its own physical laws, the potential for life is multiplied across unimaginable realms. In some of these universes, life might take forms that are beyond our wildest imagination, existing under conditions so different from our own that they challenge the very essence of what we understand as life. Finally, picture the prospect of life forms that perceive time differently. On a distant planet, biological processes might occur at vastly different rates, resulting in organisms that experience time in ways foreign to us. Entire life cycles could unfold in what we perceive as mere moments or stretch out over millennia, offering a glimpse into the diverse possibilities of existence in the universe. As you continue to relax, let your mind wander through these incredible possibilities, each a gentle nudge towards the infinite wonders that the universe has to offer. In the quietude of the night, let these thoughts cradle you into a deeper sense of tranquility and awe. Imagine drifting off to sleep, thinking about the idea of panspermia. Have you heard of it? It's the hypothesis that life might not have originated on Earth, but was instead carried here on meteoroids or comets. Picture ancient building blocks of life hitching a ride across the cosmos, seeding planets like ours with the potential for life. This notion suggests that life could be more widespread in the universe than we currently understand, potentially linking us to distant, unknown worlds. As you ponder that, let me tell you about the Drake equation, a mathematical formula developed to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It's fascinating because it takes into account factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and more. Each term is a puzzle piece in the grand search for extraterrestrial life, sparking curiosity and debate among scientists and enthusiasts alike. Let me share something intriguing about the Fermi paradox. It's the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence or contact with such civilizations. Given the vastness of the universe and the billions of potentially habitable planets, why haven't we found any signs of life? This paradox encourages us to rethink our assumptions about life and its prevalence in the universe. Did you know that the search for extraterrestrial life isn't limited to just planets and moons? Some scientists are exploring the idea that life might exist on asteroids. These rocky bodies, with their diverse compositions, might harbor the conditions necessary for microbial life. It's a reminder of the creativity and open-mindedness required in this cosmic quest. Speaking of unconventional habitats, the search for life also extends to exoplanets with atmospheres rich in hydrogen. Such environments are hostile by Earth standards, but they could potentially support microbial life forms that utilize hydrogen in their biological processes. This expands the scope of where we might find life, shifting our focus from Earth-like conditions to a broader range of possibilities. Here's a surprising twist. The search for life isn't just about finding new planets. It's also about understanding those in our own solar system better. For instance, the enigmatic red planet Mars has long been a focal point. Scientists are particularly interested in the discovery of ancient riverbeds and the possibility of underground aquifers which could hint at past or even present microbial life. Let your mind wander to the icy moons of Jupiter and Saturn. Europa and Enceladus have captured the imagination of researchers due to their subsurface oceans. The gravitational interactions with their parent planets generate heat, keeping these oceans in a liquid state beneath thick ice crusts. These hidden seas could potentially harbor life, protected from harsh surface conditions. And then there's the concept of technosignatures. Unlike biosignatures, which are signs of life itself, technosignatures are indicators of advanced technological activity, like radio signals or even massive energy-absorbing structures such as Dyson spheres. Scientists are on the lookout for these telltale signs of intelligent civilizations that might be using technology far beyond our current capabilities. Consider the possibility of life in the form of extremophiles. On Earth, these are organisms that thrive in extreme environments, such as deep-sea hydrothermal vents, acidic springs, or radiation-laden exteriors of space stations. Their resilience suggests that life can persist under conditions once thought uninhabitable, hinting at how life elsewhere might adapt to alien environments. In the realm of science fiction becoming reality, there's the notion of life on planets orbiting red dwarf stars. These stars are smaller and cooler than our Sun, and their planets are often tidally locked, meaning one side always faces the star. Despite this, stable climates might exist on the twilight edges, where life could emerge, sustained by gentle perpetual twilight. Let me take you to the concept of biofluorescence. Some researchers propose that life on planets orbiting active stars might use biofluorescence as a protective mechanism, absorbing harmful ultraviolet radiation and converting it into visible light. This adaptation could make life forms on such planets visible in a unique and mesmerizing glow. Imagine, too, the search for life in the form of airborne microbial communities. On Earth, some bacteria and fungi are known to exist in high-altitude clouds. This discovery opens the possibility that life might also thrive in the atmospheres of other planets or moons, suspended in layers of dense gas, adapting to the peculiar atmospheric conditions. Have you ever thought about the idea of life existing within the atmospheres of gas giants? While the surface conditions of planets like Jupiter and Saturn are inhospitable, their upper atmosphere layers might provide a stable environment where life could potentially exist, perhaps in the form of floating organisms buoyed by the thick gaseous envelopes. Finally, as you drift further into contemplation, consider the revolutionary idea that some extraterrestrial life might communicate in ways beyond our current understanding. Instead of using electromagnetic signals like radio waves, they might employ gravitational waves or quantum entanglement, methods that could elude our detection technologies but offer new horizons for understanding life's complexity. Let these cosmic possibilities inspire a sense of wonder, as if the universe itself is whispering its secrets to you. Drift into the night, cradled by the thoughts of what lies beyond, endlessly curious about the life that might be waiting to be discovered. As we continue our journey through the cosmos, consider the intriguing notion of panspermia. It's the hypothesis that life exists throughout the universe, distributed by meteoroids, asteroids, comets, and even space dust. Imagine tiny life forms hitching a ride through space, seeding life on different planets, including possibly our own Earth. This idea suggests that life might not have originated independently on each planet, but could be part of a vast cosmic network. Here's something that might surprise you. Scientists are investigating the potential for life in the subsurface of Mars, not just its surface. With the discovery of subsurface ice and potential aquifers, there's a possibility that life, if it exists, might be hiding beneath the planet's surface, protected from harsh radiation and extreme temperatures. On the subject of Mars, let's talk about the seasonal methane emissions detected in its atmosphere. Methane can be produced by geological or biological processes. The presence of seasonal changes in methane levels is intriguing because it hints at active processes beneath the Martian surface, possibly even microbial life. Shifting our gaze to the distant worlds, think about the role of binary star systems in the search for life. Planets orbiting two stars, much like the fictional world of Tatooine in Star Wars, face unique challenges and opportunities. The varying light and heat from two suns could create dynamic climates where life might adapt in fascinating ways. Speaking of dual stars, did you know that some scientists are looking into how life might adapt to the harsh conditions of rogue planets? These are planets that don't orbit any star and drift through space in the dark. While they lack the warmth of a nearby star, geothermal energy from their core could provide the necessary heat to sustain life, leading to entirely different evolutionary paths. And then there's the intriguing potential for life in the form of silicon-based organisms. While life as we know it is carbon-based, some scientists speculate that silicon, which shares chemical properties with carbon, could serve as an alternative building block for life, especially on planets with environments hostile to carbon-based life. Delving into our solar system again, have you ever considered the potential for life on Venus? Despite its hellish surface conditions, the possibility of microbial life in the planet's upper atmosphere, where temperatures and pressures are more Earth-like, has sparked interest. The discovery of phosphine, a gas that on Earth is associated with life, has fueled speculation about this mysterious world. Moving beyond planets, some researchers are exploring the potential for life in cosmic plumes. These are jets of material ejected from moons, like Enceladus, into space. By studying these plumes, scientists hope to find clues about the subsurface oceans and possibly signs of life. Did you know that the study of extreme environments on Earth, known as astrobiology, plays a crucial role in the search for extraterrestrial life? By understanding how life adapts and thrives in Earth's most hostile environments, researchers gather clues about where and how life might survive beyond our planet. As we ponder these possibilities, let's consider the intriguing concept of life as we don't know it. This idea encourages scientists to think beyond the parameters of life on Earth, exploring the potential for entirely different biochemical processes in alien ecosystems. It's a humbling reminder of the vastness and diversity that the universe might hold. Here's a truly out-of-this-world idea. Some scientists are investigating the possibility of life existing in interstellar space. While it might seem improbable, the notion of dormant life forms traveling through the cosmos, awakening only when they encounter suitable conditions, adds another layer of complexity to our understanding of life's resilience. On a more technological note, consider the efforts to design instruments capable of identifying biosignatures in the light spectra of distant exoplanets. These instruments, part of a field known as spectroscopy, could reveal atmospheric compositions that suggest the presence of life, offering a way to scan the skies for hints of alien ecosystems. And what of the idea of life using artificial structures for survival? Some scientists hypothesize about extraterrestrial civilizations constructing vast habitats or modifying their environments on a planetary scale. Such megastructures could be detectable by their unique signatures, offering tantalizing clues about advanced life. Reflect for a moment on the potential for life in the transient zones of planets with extreme climates. In worlds where conditions vary drastically between day and night or seasons, life might flourish in those brief windows of stability, adapting to the cyclical changes in its environment. Finally, let's not forget the role of imagination and creativity in this cosmic exploration. The very act of considering such diverse possibilities for life beyond Earth is a testament to human curiosity and the endless quest for understanding our place in the universe. Each theory, each possibility, is a glimpse into the vast tapestry of potential realities that await discovery. As you let these thoughts settle, imagine the universe as a grand storyteller with countless tales of life yet to be told. Drift gently into the mysteries of the cosmos, cradled by the knowledge that the search for extraterrestrial life is as much about exploring the boundaries of imagination as it is about uncovering the secrets of the stars. Have you ever wondered about the possibility of life on planets vastly different from our own, where conditions are not as we know them? One fascinating avenue of research considers that life could emerge in environments rich in hydrocarbons, like the lakes and seas of Titan, Saturn's largest moon. Titan's surface is covered with liquid methane and ethane, and scientists speculate that life forms using these hydrocarbons instead of water could thrive there, painting a picture of an alien ecosystem unlike any on Earth. Speaking of unusual ecosystems, consider the potential for life in the atmospheres of gas giants like Jupiter and Saturn. Some scientists suggest that floating microbial life could exist in the thick clouds of these planets, thriving in pockets of stable atmospheric pressure and temperature. The idea that life could float and drift in gaseous seas challenges our terrestrial perspective and expands the horizons of astrobiology. Did you know that Venus, often called Earth's twin, once had conditions that might have supported oceans and possibly life? Recent studies propose that Venus may have had a temperate climate and liquid water for 2 to 3 billion years before a runaway greenhouse effect transformed it into the scorching world we see today. This raises questions about whether life once existed there, and, if so, what traces it might have left behind. In the realm of the theoretical, there's the concept of panspermia, which posits that life could travel between planets on meteorites or comets. This idea suggests that life on Earth might have originated elsewhere in the universe and been seeded here by cosmic debris. Can you imagine the journey of microscopic life forms, hitching a ride across the cosmos, carrying the seeds of life from one world to another? Here's something thought-provoking: the Drake equation, a formula devised to estimate the number of active, communicative extraterrestrial civilizations in our galaxy. While it's more a tool for stimulating discussion than providing precise answers, the equation highlights the many factors involved in the search for life beyond Earth, from star formation rates to the likelihood of intelligent life developing. It reminds us of the vastness of possibilities when it comes to life in the universe. Exploring the potential for life outside our solar system, scientists have turned their attention to exoplanets within the habitable zones of their stars. These are regions where conditions might be just right for liquid water to exist. However, researchers are also considering planets and moons outside traditional habitable zones, where geothermal or tidal heating could create pockets of life-friendly conditions. This broadens the scope of our search and invites us to rethink what makes a planet habitable. Have you heard about technosignatures? These are signs of advanced technology from extraterrestrial civilizations, such as unusual patterns of light or energy that might indicate the presence of alien megastructures or communication networks. By searching for these signatures, scientists hope to catch a glimpse of intelligent life beyond Earth, opening up a new frontier in the search for extraterrestrial intelligence. On a smaller scale, the study of extremophiles on Earth, organisms that thrive in extreme conditions, provides valuable insights into how life might adapt to harsh environments elsewhere in the universe. These resilient creatures, found in the deep ocean, volcanic vents, and icy deserts, offer clues about how life could persist on distant worlds with seemingly inhospitable conditions. Here's a delightful thought: the concept of shadow biospheres, or undiscovered forms of life that exist alongside known life on Earth. This idea suggests that alternate biochemistries might exist right under our noses, and discovering such life forms could revolutionize our understanding of biology and the potential for alien life. Contemplating the search for life, one can't help but be intrigued by the idea of artificially created life. Scientists are exploring the possibility of synthesizing life in the lab, which could provide insights into how life might arise in the universe. By understanding the fundamental processes that lead to the emergence of life, we might better predict where and how it might exist beyond Earth. And have you considered the role of artificial intelligence in the search for extraterrestrial life? With the vast amount of data collected from telescopes and space probes, AI is being used to sift through information, identify patterns, and make discoveries that might be missed by human researchers. This collaboration between human intelligence and machine learning could accelerate our quest to find life in the cosmos. Looking up at the night sky, we might ponder the Fermi paradox, which questions why, given the high probability of extraterrestrial civilizations, we have yet to detect any signs of them. The paradox invites us to consider the many factors that could explain the silence, from the possibility that civilizations are short-lived to the idea that they might be deliberately avoiding contact. Finally, let's reflect on the sheer diversity of star systems in our galaxy and the multitude of planets that orbit them. With each discovery, our picture of the universe becomes more intricate and colorful, reminding us that the cosmic quest for life is as much about embracing the unknown as it is about seeking answers. As you drift into the realm of dreams, let the wonder of these possibilities lull you into a restful sleep, comforted by the knowledge that the search for life beyond Earth continues to expand the horizons of our imagination and understanding. Imagine, if you will, a world where telescopes are not just instruments of observation, but rather windows into the unknown. The Very Large Array in New Mexico, a field of radio antennas, listens to the cosmos day and night, capturing whispers from distant stars. Did you know that this array has been pivotal in searching for extraterrestrial signals? It's like trying to catch a needle in the cosmic haystack, but the possibilities are as vast as the universe itself. Speaking of signals, are you familiar with the WOW signal? In 1970, a strong and unexplained signal was detected by the Big Ear radio telescope in Ohio. It lasted 72 seconds and was never detected again, leaving scientists baffled and hopeful that it might have been a message from an alien civilization. Imagine the thrill of discovering such a signal and the endless questions it raises. Here's an intriguing thought. Some researchers are exploring the idea of biosignatures beyond the usual carbon-based life. They consider the possibility of silicon-based life forms, as silicon shares chemical properties with carbon. This idea challenges our carbon-centric view of life and opens doors to imagining life in environments vastly different from Earth. Have you ever wondered about the concept of Dyson spheres? These hypothetical megastructures, named after physicist Freeman Dyson, would encompass a star to capture its energy, suggesting the presence of advanced civilizations. Searching for such immense structures in the universe could help us detect technologically advanced extraterrestrial societies. Transitioning from the vastness of megastructures to the microcosm, think about the possibility of nanotechnology in alien life forms. Some scientists speculate that intelligent extraterrestrial beings might employ nanotechnology to manipulate their environments or even themselves, offering a different perspective on intelligence and adaptation. Now, consider this. The moons of our solar system, often overshadowed by their planet counterparts, are gaining attention in the search for life. Europa, a moon of Jupiter, has a subsurface ocean beneath its icy crust, raising hopes for life forms thriving in its depths. Similarly, Saturn's moon, Enceladus, has geysers spewing water vapor, hinting at hidden oceans that might harbor life. Did you know our search for extraterrestrial intelligence also involves listening for techno-signals from other galaxies? While the distances are mind-boggling, breakthroughs in technology allow us to eavesdrop on cosmic conversations millions of light years away. It's a humbling reminder of the universe's grandeur and the potential for distant neighbors. In a more speculative realm, some thinkers propose that extraterrestrial life might communicate through mathematics or music. Such universal languages could transcend the barriers of time and space, offering a unique way to bridge the gap between vastly different forms of life. Can you imagine deciphering an alien melody or equation? Here's a fascinating aspect of space exploration: the role of space probes in searching for signs of life. NASA's Perseverance rover on Mars is diligently collecting samples that might contain ancient microbial life, and future missions aim to bring these samples back to Earth for analysis. Each new mission is a step closer to unveiling the secrets of our celestial neighbor. On a more philosophical note, there's a notion that extraterrestrial life might exist in forms we cannot currently comprehend. This challenges our understanding of consciousness and intelligence, suggesting that our search might need to evolve beyond traditional scientific methodologies. It's a reminder of how little we truly know and how much there is to learn. Did you know that scientists are also considering the role of dark matter in the search for life? While dark matter remains one of the universe's greatest mysteries, understanding its properties could potentially reveal habitats or conditions conducive to life in places we cannot yet see or imagine. And let's not forget the tantalizing possibility that life might exist within the atmospheres of gas giants. While harsh and tempestuous, these environments could harbor floating ecosystems, challenging the notion that solid ground is necessary for life. It's a vision of life, literally adrift in a sea of clouds and storms. Transitioning now to the realm of theoretical physics, some speculate about the existence of parallel universes where extraterrestrial life might thrive. While currently a topic of science fiction and theoretical discussion, the multiverse theory expands our quest for life to dimensions beyond our own, offering boundless realms of possibility. Lastly, consider the impact of art and culture on our understanding of extraterrestrial life. From science fiction literature to blockbuster films, these narratives shape our imaginations and expectations, influencing how we perceive the possibility of life beyond Earth. They remind us that the search is not just scientific, but also deeply rooted in our human desire to connect with the unknown. As you reflect on these wonders, let your imagination wander through the cosmos, where each star might host a story yet to be discovered, each planet a possibility waiting to be explored. Let the mysteries of the universe be a gentle lullaby, guiding you into a peaceful slumber filled with dreams of distant worlds and the endless search for companionship among the stars. Imagine drifting through the cosmic sea, where every wave might carry whispers from civilizations unknown. Did you know that the concept of panspermia suggests that life on Earth might have originated from microbial organisms hitching a ride on comets or meteorites from distant worlds? This intriguing hypothesis implies that life could be more interconnected across the universe than we ever imagined. Think about the vast implications of such an idea. What if we are all cosmic travelers, our origins shared with beings light years away? Speaking of connections, consider the search for exoplanets in habitable zones, those sweet spots around stars where liquid water could exist. Astronomers have identified thousands of these exoplanets, with missions like the Kepler Space Telescope leading the charge. But here's the twist. More recent discoveries suggest that some exoplanets might have atmospheres rich in hydrogen, which could create conditions suitable for life, even at greater distances from their stars. It's a reminder of the universe's capacity to surprise us and challenge our assumptions. Here's something that might pique your curiosity. Researchers are developing artificial intelligence to sift through massive amounts of cosmic data, searching for patterns that could indicate extraterrestrial technology. This sophisticated approach allows us to comb through the noise of the universe with unprecedented precision, like finding a whisper in a bustling crowd. Can you imagine the moment when AI uncovers the first hint of another civilization's handiwork? In our own solar system, tiny celestial bodies like asteroids and comets are turning out to be more than just space rocks. Some scientists believe these objects could harbor microbial life within their icy interiors. Missions like ESA's Rosetta, which landed on a comet, offer tantalizing glimpses into these mysterious worlds. The idea that life might exist in such unlikely places challenges our understanding of habitability and beckons us to look beyond traditional confines. Now, let me share a thought-provoking notion, the Fermi paradox, which questions why, given the multitude of stars and potential for life, we haven't encountered any extraterrestrial civilizations. One possibility is the Great Filter hypothesis, suggesting that life might often self-destruct before achieving interstellar communication. It's a sobering reminder of the delicate balance required for survival and the resilience needed to explore the stars. Speaking of exploration, the search for life extends beyond planets and moons to the vastness of interstellar space. Some scientists are investigating the potential for life in the form of space plankton, microscopic organisms that might drift between stars, carried by stellar winds. This concept expands the boundaries of what we consider viable habitats, painting a picture of life as a universal nomad. In a more theoretical realm, the idea of quantum communication with extraterrestrial beings has been proposed. Quantum entanglement, a mysterious phenomenon where particles become interconnected regardless of distance, might offer a method for instantaneous communication across the cosmos. It's a tantalizing thought, a conversation with an alien civilization not bound by the speed of light. Here's another fascinating perspective: the potential for extraterrestrial intelligence to reside in non-biological forms. Some theorists propose that advanced civilizations might transcend biological limitations, existing as digital consciousness within machines. This raises profound questions about the nature of life and intelligence, challenging us to broaden our definitions and expectations. Now, let's delve into the realm of biomimicry, where scientists look to nature for solutions to technological challenges. Some researchers speculate that extraterrestrial technologies might also be inspired by nature's designs, leading to innovations in energy, propulsion, and communication. By observing the universe through this lens, we might uncover clues to alien engineering hidden in plain sight. Have you ever pondered the idea of life's precursors forming in the energetic environments of young stars? Some astronomers believe that complex organic molecules, the building blocks of life, might assemble in the intense radiation and magnetic fields surrounding newborn stars. This process could seed star systems with the ingredients for life, like cosmic gardeners tending to an interstellar nursery. And here's a captivating insight: the study of extremophiles, organisms that thrive in Earth's harshest environments, offers valuable lessons in the search for extraterrestrial life. From the searing heat of hydrothermal vents to the frigid depths of Antarctic ice, these resilient life forms demonstrate the astonishing adaptability of life. They remind us that where there's a will, there's always a way, even in the most inhospitable corners of the universe. Lastly, think about the implications of cultural perspectives on our quest for extraterrestrial life. Across the world, different cultures interpret the search for life through unique lenses, influenced by history, spirituality, and philosophy. This diversity of thought enriches the scientific endeavor, fostering a global dialogue and cooperation that transcends borders. As you drift into the realm of dreams, let these wonders of the cosmos inspire your imagination. Picture worlds beyond our own where life might flourish in forms and places we have yet to conceive. Embrace the mystery of the universe as a gentle lullaby, guiding you to sleep with the promise of discovery and the hope of finding our cosmic kin. Let me take you on a journey to the moons of our solar system, where some scientists believe the most promising candidates for extraterrestrial life might reside. Have you heard of Europa, one of Jupiter's icy moons? Beneath its frozen surface lies a vast ocean, kept warm by tidal heating. This dynamic environment could harbor life in ways similar to Earth's deep-sea hydrothermal vents. Imagine the possibility of alien sea creatures swimming beneath layers of ice, existing in a world so different from our own. And speaking of oceans, consider Saturn's moon, Enceladus. Did you know that powerful geysers spew water vapor and ice particles from its southern hemisphere? These plumes contain organic compounds, hinting at the chemical building blocks of life. It's as if Enceladus is whispering clues about its secrets, urging us to listen more closely. Let's drift a bit further out, to Titan, another of Saturn's moons. Titan is unique with its thick atmosphere and lakes of liquid methane and ethane. Some scientists speculate that life could exist here in forms unimaginable to us, perhaps using methane as a solvent instead of water. This challenges our Earth-centric view of habitability and invites us to expand our horizons. Moving beyond our solar system, have you ever wondered about planets orbiting binary star systems? These are systems with two suns, much like the fictional world of Tatooine from Star Wars. Planets in such environments experience complex gravitational interactions, leading to intriguing climates and potentially habitable zones. The dance of these celestial bodies creates a celestial ballet, an awe-inspiring spectacle that might yet harbor life. Here's a whimsical thought. The concept of panspermia suggests that life might travel between planets and star systems via meteoroids and comets. Imagine the journey of a microscopic life form hitching a ride across the universe, seeding life wherever it lands. It's a captivating idea that life is not only resilient but also adventurous, spreading its tendrils far and wide. Now, let's turn our gaze inward, to the intricate world of biology. Scientists have discovered that some terrestrial bacteria can survive the harsh conditions of space, enduring extreme radiation and vacuum. This resilience suggests that if life exists elsewhere in the universe, it too might exhibit astonishing durability, thriving in environments we might deem hostile. Consider for a moment the notion of biosignatures, chemical indicators of life that scientists search for in exoplanet atmospheres. The presence of gases like oxygen and methane in certain ratios can hint at biological processes. It's like a cosmic detective story where scientists piece together clues from afar to solve the puzzle of life beyond Earth. On the technological front, the development of advanced telescopes such as the James Webb Space Telescope will soon allow us to peer deeper into the universe than ever before. These instruments are not just tools but time machines, capable of observing the light from distant worlds, giving us glimpses of their past and potential for life. Have you ever considered the possibility of extraterrestrial life existing in forms unlike anything we've seen before? Some theories propose that life might arise from chemical elements other than carbon, or function in entirely different biological paradigms. This not only broadens our search, but also challenges our imagination, prompting us to redefine what it means to be alive. Another intriguing concept is the search for technosignatures, which are indicators of advanced technological civilizations. These could include unnatural patterns of light or radio waves, structures that obscure a star's light, or even artifacts of massive engineering projects. The quest for technosignatures is a testament to our curiosity, pushing the boundaries of exploration beyond biological life. Speaking of exploration, there's an exciting notion that life might leave its mark on rocky bodies through chemical weathering or specific mineral deposits. This form of geological biosignature, preserved in the rock record, could tell stories of past or present life, waiting for us to uncover them. Let's not forget the fascinating prospect of contact with microbial extraterrestrial life through future space missions. The return of samples from Mars or the icy moons could bring with them the first direct evidence of alien life. It would be a monumental moment in human history, reshaping our understanding of life's potential in the universe. And just when you thought it couldn't get any more intriguing, consider the hypothesis that intelligent extraterrestrial beings might choose to observe Earth silently, much like researchers observing wildlife from a distance. This is known as the zoo hypothesis, suggesting that advanced civilizations might be studying us while remaining hidden, respecting our natural development. Lastly, ponder the influence of fictional portrayals of extraterrestrial life on scientific inquiry. Stories of aliens and far-off worlds ignite our imagination, inspiring generations of scientists to explore the cosmos. These narratives, while fictional, fuel our dreams and drive the real-world quest to uncover the mysteries of space. As the night envelops you, let these stories of exploration and possibility cradle you into a restful slumber. May the wonders of the universe fill your dreams with visions of distant stars and the promise of new discoveries. Embrace the vastness of the cosmos, knowing that every question leads us closer to understanding our place in the grand tapestry of existence. As you rest your mind and let these thoughts settle, let's dive deeper into some surprising avenues of our search for extraterrestrial life. Imagine for a moment the vastness of our own Milky Way galaxy, home to an estimated 100 billion stars. Among these countless stars, it's believed that there could be as many as 6 billion Earth-like planets. Can you picture the sheer number of worlds, each with its own mysteries? This staggering possibility fuels our quest to find life beyond our planet. Speaking of stars, did you know that our Sun is considered a relatively quiet star? Many stars in the universe are far more active, emitting powerful solar flares that could strip a planet's atmosphere. The existence of life around such stars would require adaptations we've yet to understand. It's a humbling reminder of the delicate balance life on Earth enjoys and how varied conditions could be elsewhere. Here's another captivating thought. Scientists have discovered exoplanets in the habitable zones of their stars, regions where conditions might be just right for liquid water to exist. But these planets often have extreme conditions, like tidally locked rotations, where one side always faces the star, resulting in perpetual daylight, while the other is plunged in eternal night. Life on such worlds would need to be incredibly adaptable to survive in such stark environments. Moving from stars to the smallest of particles, consider this intriguing possibility: neutrinos. Those nearly massless particles that zip through the universe, barely interacting with matter, could be a form of communication used by advanced civilizations. These elusive particles can pass through entire planets undetected, making them a perfect medium for interstellar messaging. It's a thought that stretches the boundaries of our technological imagination. Have you ever wondered about the role of rogue planets? Those that drift through space without a host star. These planets might still harbor life, sustained by internal heat or chemical reactions. It's a reminder that life could exist in unexpected corners of the cosmos, even in the depths of space between the stars. On the topic of life itself, think about how extremophiles on Earth inhabit environments once thought uninhabitable, such as hydrothermal vents on the ocean floor or acidic lakes. Their resilience gives us hope that life could thrive under conditions we haven't yet considered, possibly even in the clouds of Venus, where scientists have detected phosphine, a potential indicator of biological activity. Delving into the realm of the very small, some researchers are exploring the idea that life could exist at a microscopic level on dust particles floating through space. These cosmic specks might carry the seeds of life from one celestial body to another, a concept that ties back to the idea of panspermia, suggesting that life is more interconnected than we might think. Now, let's consider the potential of artificial intelligence in our search for extraterrestrial life. AI systems can analyze vast amounts of data from telescopes and spacecraft far more efficiently than humans. This technology could uncover signals or patterns that hint at the presence of alien life, accelerating our efforts to make contact with other civilizations. Here's a thought-provoking idea: the study of dark biospheres, ecosystems that could exist beneath the surface of planets or moons, shielded from the harshness of space. These hidden worlds might be teeming with life, thriving in complete darkness. Such ecosystems challenge our understanding of where life can exist and what it might look like. Imagine, if you will, the potential for virtual reality to simulate environments on distant worlds. Scientists can use these simulations to explore how life might adapt to different atmospheric and gravitational conditions. It's a powerful tool that allows us to push the boundaries of our imagination and consider possibilities that might otherwise seem out of reach. Have you ever considered the implications of discovering microbial life on Mars or Europa? Such a finding would fundamentally change our understanding of life's prevalence in the universe, suggesting that life might be a common occurrence rather than a unique event. It would prompt us to reevaluate the conditions necessary for life and expand our search to environments previously dismissed. On a more philosophical note, the quest for extraterrestrial life raises profound questions about our own existence. Are we truly alone in the universe, or are we just one of countless civilizations scattered among the stars? The search for an answer is as much about understanding ourselves as it is about discovering others. The possibility of contacting an advanced civilization also invites us to consider the implications of such a discovery. How would it affect our societies, our religions, our understanding of our place in the cosmos? The potential for cultural and scientific exchange is both exhilarating and daunting, offering a glimpse into a future of unprecedented possibilities. As we drift further into these thoughts, consider the impact of space exploration on our planet. The technologies developed in our search for life have led to innovations that benefit life on Earth, from medical advancements to new materials. It's a testament to the interconnectedness of exploration and the betterment of human life. Finally, as you let these musings carry you into a serene slumber, remember that the search for extraterrestrial life is as much about asking questions as it is about finding answers. It's a journey that invites us to ponder the vastness of the universe and our place within it, sparking a sense of wonder that transcends the boundaries of our planet. As you close your eyes, let the stars guide your dreams and inspire your imagination, for the universe is vast and its mysteries are endless. Continuing our celestial journey, have you ever pondered the intriguing notion that the universe might be teeming with life that we simply cannot perceive? Just as our eyes are blind to ultraviolet and infrared light, perhaps our senses and instruments are similarly limited when it comes to detecting certain forms of life. Imagine if entire ecosystems thrived on wavelengths or frequencies that we have yet to discover. This possibility invites us to broaden our perspective and consider that life might exist in forms beyond our current comprehension. Isn't it fascinating to consider the role of quantum communication in interstellar messaging? While neutrinos present one possibility, the principles of quantum entanglement could offer another. This phenomenon, where particles become interconnected regardless of distance, might one day enable instantaneous communication across vast cosmic expanses. It sounds like science fiction, yet researchers are actively exploring how this could revolutionize our search for extraterrestrial intelligence. Speaking of revolutionary ideas, did you know that some scientists are investigating the potential of microbial life to alter the atmosphere of a planet? On Earth, microbes have played a significant role in shaping our environment, such as oxygenating the atmosphere billions of years ago. If similar processes occur on other planets, detecting changes in atmospheric composition could be a key indicator of life. This approach adds another layer to our toolkit in the quest to find life beyond our world. Have you ever considered the possibility that life on other planets might not use water as its primary solvent? While water is essential for life as we know it, other liquids, like ammonia or methane, might serve similar roles in alien biochemistry. Saturn's moon Titan, with its methane lakes, presents an intriguing case study for this hypothesis. It challenges us to redefine our criteria for habitability as we explore the cosmos. Another captivating concept is the use of gravitational waves to probe the universe for life. These ripples in space-time, caused by massive cosmic events, could contain information about the presence of life in distant star systems. Gravitational wave astronomy is still in its infancy, but it holds the potential to unlock new insights about the universe's most enigmatic phenomena, including the existence of other civilizations. Here's something to spark your imagination: the idea of solar sails powered by laser beams to propel spacecraft to distant stars. This technology, reminiscent of ancient seafaring, could enable humanity to explore exoplanets within our lifetime. By harnessing the momentum from focused light, solar sails offer a promising avenue for interstellar exploration, potentially bringing us closer to other worlds and whatever life they might host. As you drift deeper into these cosmic thoughts, reflect on the notion of time capsules traveling between stars. Some scientists propose that advanced civilizations might send probes containing information about their culture and technology, like a cosmic message in a bottle. If such capsules exist, they could be drifting through our solar system right now, waiting to be discovered and deciphered by us. And have you ever wondered about the concept of a shadow biosphere on our own planet? Some researchers hypothesize that life might exist on Earth in forms we have yet to recognize, using biochemistries distinct from known life. Such organisms, if they exist, could provide insights into how life might evolve under different conditions elsewhere in the universe, broadening our understanding of life's potential diversity. Consider also the possibility that planets orbiting red dwarf stars, the most common type of star in the galaxy, might host life. These stars burn cooler and longer than our Sun, offering a stable environment for planets to develop and sustain life over billions of years. However, their frequent flares pose challenges for life, prompting scientists to explore how organisms might adapt to such volatile conditions. The concept of technosignatures is another exciting avenue in our search for extraterrestrial life. These are indicators of advanced technological activity, such as radio signals, artificial lighting, or even waste heat from megastructures. By broadening our search to include these signs, scientists hope to detect civilizations that might be communicating or altering their environments on a grand scale. And let us not forget the intriguing role of cosmic dust in the search for life. These tiny particles, drifting through space, can carry organic molecules and potentially even simple life forms from one planet to another. This cosmic exchange could be a mechanism for spreading life throughout the galaxy, suggesting a more interconnected view of the universe's ecosystems. As you let these ideas take root in your mind, imagine the possibility of microbial life surviving the harsh conditions of space travel. On Earth, certain extremophiles can endure radiation and vacuum, sparking the idea that similar organisms could hitch rides on meteorites, spreading life across celestial bodies in a cosmic relay of sorts. And finally, consider the profound implications of discovering life in unexpected places, like the icy moons of Jupiter and Saturn. Such a discovery would not only expand our understanding of life's adaptability, but also pave the way for future missions as humanity continues its quest to uncover the secrets of the universe. As you drift into a peaceful slumber, let these thoughts fill your dreams with wonder. Remember, the universe is vast and full of mysteries waiting to be unlocked. In the quiet of the night, as stars twinkle above, let your imagination soar among the stars, pondering the endless possibilities of life beyond our world. As you nestle into your cozy space, let me share a thought-provoking idea with you, the concept of panspermia. This theory suggests that life on Earth might have originated from microorganisms or chemical precursors of life present in outer space, delivered here by comets, meteoroids, or asteroids. Imagine the vast cosmic ocean as a cradle of life, sending seeds across the universe to sprout on fertile planets. It's a narrative that links us to the stars in a deeply interconnected web of existence. Here's something else to ponder. The mysterious radio signal known as the WOW signal, detected in 1977. It was a strong, narrowband radio signal received by the Big Ear radio telescope and lasted 72 seconds. The signal originated from the direction of the constellation Sagittarius, and despite numerous attempts, it has never been explained or replicated. Could it have been an attempt at cosmic communication, or just an intriguing anomaly? Such puzzles invite us to remain ever curious and open-minded. Moving on, have you ever heard about the Drake equation? It's a formula proposed by astronomer Frank Drake in the 1960s to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. While each term in the equation involves significant uncertainties, its mere existence highlights the scientific endeavor to quantify the unknown and search for life beyond Earth in a methodical way. Speaking of methodical searches, Did you know that some scientists are exploring the potential of quantum communication to detect extraterrestrial signals? By exploiting the peculiar properties of quantum entanglement, researchers hope to develop a means of communication that might bypass the limitations of vast interstellar distances and offer a new dimension to our search for intelligent life. And here's a fascinating consideration: the potential role of artificial intelligence in our extraterrestrial pursuits. AI systems are being developed to analyze vast data sets collected from telescopes and space missions, helping us identify patterns and anomalies that might suggest the presence of life. With AI's assistance, we might uncover signals or signs that human analysts could easily overlook. Have you ever imagined the role of rogue planets in the search for life? These are planets not bound to any star, wandering through the galaxy in the cold darkness of space. Intriguingly, some of these rogue planets might still host life, warmed by the decay of radioactive elements or internal geological activity, offering a unique kind of habitat far removed from the warmth of a sun. This leads us to another intriguing idea: the search for biosignatures, not just on planets, but within their atmospheres. Techniques are being refined to analyze the light that passes through a planet's atmosphere when it transits its star. By studying absorption patterns, scientists can deduce the presence of gases that might indicate biological activity, like oxygen or methane, even from light years away. Another unexpected avenue is the study of meteoritic materials. Some meteorites that land on Earth contain complex organic compounds, hinting at the possibility of life's building blocks being widespread throughout the cosmos. These cosmic visitors offer a tantalizing glimpse into the chemical diversity of the universe and its potential to foster life. Let's not forget the intriguing experiment of simulating extraterrestrial environments here on Earth. By recreating conditions found on other planets or moons in the laboratory, scientists can study how various forms of life might survive and adapt, providing insights into what we might find elsewhere in the universe. As you relax into your pillow, consider the intriguing concept of astrobiology, a field that combines biology, chemistry, and astronomy to explore life's potential in the universe. It challenges our understanding of life and encourages us to imagine forms and processes that might be starkly different from those on Earth. On a more speculative note, some researchers are exploring the idea of asopsychology, contemplating how contact with extraterrestrial life might impact human psychology and society. What cultural shifts might occur? How would our perception of ourselves change when faced with the knowledge that we are not alone? Speaking of societal impacts, the discovery of extraterrestrial life, even in microbial form, would have profound philosophical and religious implications. It might prompt us to revisit age-old questions about our place in the cosmos, our origins, and our future. Here's an imaginative notion: the potential for life beneath the surface of planets or moons. Subsurface oceans, like those possibly existing on Jupiter's moon Europa or Saturn's moon Enceladus, could harbor life in environments shielded from harsh surface conditions. These hidden water worlds remind us that life might thrive in the most unexpected places. As you drift further into contemplation, ponder the possibilities of communication with extraterrestrial intelligence. Some have proposed using universal mathematical concepts or musical patterns as a common language, assuming that math and music might transcend planetary boundaries and be understood by other civilizations. Before you slip into a restful slumber, imagine the profound discovery of fossilized remains of past life on Mars or another celestial body. Such a find would reveal that life once blossomed beyond Earth, forever altering our understanding of history and the resilience of life itself. As you let these thoughts swirl gently in your mind, remember that the universe is vast and full of wonders yet to be discovered. In the quiet embrace of night, let your dreams carry you across the stars, exploring the cosmos and its infinite possibilities of life beyond our world.